Hello. What we're going to look at today are some proofs using what we've learned so far about parallel lines, transversals, and the special angle relationships that spring up because of parallel lines and transversals. There's one more theorem I'd like to introduce really quick before we do these proofs. We're not going to see it in the proofs in these examples, but it's just another one that's good to have in our back pocket for future reference, and that is the transitive property of parallel lines. If you have two lines that are parallel to the same line, they are parallel to each other. So what this is saying is if we know that P and Q are parallel and that Q and R are parallel, we can directly say that P is parallel to R. This is the same idea with if A equals B and B equals C, then A equals C. That's your transitive property with using equations. We can do things similarly with parallel lines, and that's what this theorem is all about. However, let's go ahead and take a look at some proofs together because that's the main focus for today. Just like in the past, I will give you the given information and usually a picture, and you will fill in the missing statements and or reasons. For this one, all the statements are given to you. You just need to fill in the reasons. I have given you a reasons bank, just like we have used in the past. So they've given us that angle 4 is congruent to angle 5. You can see those are also marked in the picture. They want us to prove that G is parallel to H. So angle 4 is congruent to angle 5. How do we know that? Well, that information was given. So our reason here is given. Next up, next statement is angle 1 is congruent to angle 4. How can we say that? So let's look at the picture. Here's angle 1, here's angle 4. Those two angles are vertical angles. Anytime you have two vertical angles, they are always congruent. So we're saying that angle 1 is congruent to angle 4, and we have used vertical angles for that. So vertical, I'm going to abbreviate here, vertical angles congruence theorem. Okay, next step. For our next step, they are saying that angle 1 is congruent to angle 5. So here's angle 1, here's angle 5. What kind of relationship do those angles have with each other? Actually, no, let's back up. For this, we want to look back at steps 1 and 2. Here I have angle 4 is congruent to angle 5, and I have angle 4 is congruent to angle 1. Since angle 4 is part of both of those, I can use the transitive property to say that angle 1 is congruent to angle 5. So this one is with the transitive property, which we talked about just a second ago. All right, and then last but not least, they say G is parallel to H. Well, why can we say that for sure? We have angle 1 and angle 5 being congruent. Angle 1 and angle 5 are corresponding angles. So by the corresponding angles converse, when I have two congruent corresponding angles, then I have two parallel lines, which happen to be G and H. So this one is the corresponding, I'm going to abbreviate again, angles converse theorem that we talked about in the last lesson. All right, so that one wasn't too bad. Let's try one more. This proof's a little longer, and this time I've mixed together statements and reasons that you need to fill in. Okay, so we have our picture here. They've given us that P is parallel to Q. We can see that with these parallel arrows there. And they are telling us that angle 1 is supplementary to angle 2. I'm going to erase these little marks here before we get too carried away. So, first statement, angle 1 is supplementary to angle 2. How do we know that? We know that because they tell us. And so since they tell us that, that falls under given. Next up, they say the reason for whatever we say next is the definition of supplementary angles. What does the definition of supplementary angles say? The definition of supplementary angles says that two supplementary angles add up to 180. The two angles we're talking about are angle 1 and 2. So what we can say, since they are supplementary, is that measure of angle 1 and measure of angle 2 add up to 180 degrees. Again, using our supplementary angles definition. The next reason they've given us is just given. So what was the other piece of given information? The other piece of given information is P is parallel to Q. Remember, those two lines there means parallel. So that's all we can do there. That's the stuff that they've given us. All right. Now the next step says that angle 2 is congruent to angle 3. So let's look at, we have these two parallel lines P and Q. What kind of relationship do angle 2 and angle 3 have? In this diagram, angle 2 and angle 3 are alternate interior angles, these two angles right here. Alternate interior angles are congruent, and so we can say that angle 2 and angle 3 are congruent by the alternate interior angles theorem. Again, I'm going to abbreviate. Okay. So now that those angles are congruent, usually the next thing that we say, after we say that two angles are congruent, usually the next thing we do is we say that their measures are equal. So instead of saying angle 2 is congruent to angle 3, I'm going to say measure of angle 2 is equal to measure of angle 3. That all stems from our definition of congruent angles. When two angles are congruent, they have equal measures. All right. Next one, we jump into an equation. It says measure of angle 1 plus measure of angle 3 equals 180. This looks a lot like the equation we did in step 2, except for instead of measure of angle 2, we now have measure of angle 3. I've substituted measure of angle 3 for measure of angle 2 since they are equal. And so since I replaced or substituted, my reason for saying that is the substitution property of equality. Alrighty. And then kind of working backwards of what we did before. So we know measure of angle 1 and measure of angle 3 equal 180. Angles that equal 180 or add up to 180 degrees are supplementary. So once again, we've used that definition of supplementary angles, just kind of in the reverse order that we did towards the beginning. All right, last but not least, we are concluding that line R is parallel to line S. How and why are we saying that? Well, the last thing we said was that 1 and 3 are congruent. Angle 1 and angle 3, these two angles right here, are consecutive interior angles. When consecutive interior angles are congruent, then the two lines end up being parallel, the two lines that are the parallel line in that situation. And so since 1 and 3 are supplementary, that means R is going to be parallel to S. And again, using that angle of idea of consecutive interior angles. And that finishes our proof. That is it for today with proofs. Hopefully you're feeling really comfortable like a proofs rock star with these. Let me know if you have any questions. I hope you have a wonderful day.